Today we're going to take a look at solving linear systems. We're going to do this in a number of ways. We're going to do our linear systems with graphically using our graphing calculator, and then also algebraically. Now we're going to stick to the matrix on the graphical, but just remember, just like we talked about yesterday, when two lines intersect, we have a solution. This is true of systems of equation. All right, we'll also identify regions that satisfy systems of inequalities. All right, we'll jump right into some examples here. So the first thing we're going to take a look at is a system of equation that is set up really quite well for elimination. The thing you have to remember when solving for a system is you cannot solve for two variables at one time. So what we have to do is either substitute one of the variables out or eliminate it where we're only solving for one. Now we stack this just like our elementary school arithmetic, where we add the numbers above and below one another. When we are doing this, you want to make sure that you stack up everything. That would be the x's, the y's, the equal sign, and then the constant values. If you happen to be missing a letter or a constant value of 0, you still put them over each other and you hold the space. All right, the reason why I said this one is set up so well for elimination is because the x values are opposite values, and we're going to add here. So when I have 10x minus 10x, they eliminate. And that's why it is called the elimination method. Now, if both of your variables happen to eliminate, you have a special case. We'll talk about that on a later date, but ours do not, because we see we have a negative 2y and a positive 9y. So when we combine that, we get 7y. And then we move over to the other side and we subtract 18 by 46, negative 46, and we're going to get a negative 28. And then from here we just have a equation with one variable like we were looking for, elimination. We eliminated x and now we're just solving for y. So the 7y needs to be divided by 7 in order to get the y value, which y value would be equal to negative 4. Now when we're solving for a system, the solution is an ordered pair. We have half of that right now. We have the negative 4, but we have the x value yet to go. So what we can do on our x value is we can substitute in our y to either of equations that we started with and then solve for the x value. So I'm going to go ahead and jump up to the top here. The reason why I chose this one is because I noticed that the x value is positive, so maybe that's more likely to give me working with positive numbers. So I go 10x minus 2y, I'm going to put the y for now, equals 18. Well, we use y to represent an unknown number, but y is no longer unknown. Y is the number negative 4. So we multiply negative 2 times negative 4, and that gives us positive 8. And then again, here we are with an equation with only one variable. So we're going to solve. We do this by subtracting our 8 from both sides, and that gives me 10. 10x equals 10. We divide both sides by 10, so we now learn that the x value is equal to 1. We technically do not have the solution to the system yet. The solution to the system is an ordered pair. It's a location. So we have to take our 1 and put it back over here. And what we've learned is the solution to this system is 1, negative 4. So we have another system of equation that's going to take a little bit of work. And I chose this one. It's a little tougher because just like the other one, we had our x values already set to eliminate. You can see when we stack our values here, nothing is set to eliminate. One surefire way that you can do on this, and I'm not going to do this, I want to show you a trick that you probably have not seen. What you can do is multiply the bottom by the leading term in the top, which is 7, and then multiply the top by the leading term in the bottom, which is 4. Now, one of these has to be negative. Which one is up to you? You can choose. You were probably taught this. After this, you would eliminate. But I want to show you something to kind of think over. And if you like it, use it. If you don't, you don't have to. So you were probably taught that, okay, I'm going to multiply to get a number to eliminate. But I don't know if you've ever thought about dividing. So you've got to kind of pay attention when you do this. But if you'll notice, if I were to divide the entire top by 7, the output would be negative x plus y equals 1. So I divide that thing out and it gets me to much smaller numbers. So I can multiply them to make them meet, or I can divide to make them meet as well. So I'm going to go to the same part over here. Now the y's could get equal to 1 if I divided this by 2. But let's think about this for just a second. If I divide by 2, this is going to give me a positive y, which does not cancel another positive y. So what I'm going to do instead is not divide by 2, but divide by negative 2. So each of these terms get divided by negative 2. Negative 4 divided by negative 2 is positive 2x. 2y divided by negative 2 is negative y, so those are set to be opposite. And then negative 14 divided by negative 2 is 7. So I don't know if anybody was ever taught this method. You can divide them down to where you get them to eliminate. So you see I've done that. My y's are now set to eliminate. So I'm going to let that happen. The y's are going to cancel each other out because they're opposite. My x's are going to become negative x and 2x makes x equals 1 plus 7 is 8. So we get an x value equal to 8. Now we need to take this x value and substitute it in to find our y value. Now the nice thing is we actually have 4 equations. One equation here, 2, 3, and 4, because these are all equivalent. So I'm going to choose the one that looks the easiest. For me, it looks like the third equation is going to be the easiest one to use, because it says negative x plus y equals 1. Well, we just learned that x is not x, but it's 8. So negative 8 plus y equals 1. So I'm going to add the 8 to the other side. And what I learn is y is equal to 9. Again, I don't have a solution here. I have all the parts to a solution, but I don't have a solution quite yet. The solution is going to be the ordered pair, and the ordered pair is x value 8, y value 9. So the solution is the ordered pair 8, 9.